Welcome back to Geometry, Chapter 6, Section 7 in this book. We've been talking about shapes. That sounds easier than it is. Today we're going to talk about area of shapes. Now, this is really important why I want to get into your head. That there are a bunch of different formulas for area of these shapes, but they really all boil down to the same thing. And if you understand the basics, even if you forgot the formula, you could MacGyver it. Now, what do I mean by that? Back in the 80s, or no, it was the 90s, maybe, there was a show, I would think it's the 80s because he had a mullet. But anyway, there was a guy who was getting into trouble and then he'd look around and he'd do some science with whatever was on hand. So I have tutored kids for ages for getting ready for the SAT, the ACT and stuff like that, and then they come back later and tell me how they did. And the thing that hurts my heart is when they get to the geometry part and they look at something that they should know and they blank out and get it wrong. I had a girl one time who she said she forgot the area of a square and then she just guessed and got it wrong. Well, the only thing is if you will just remember one formula really, really well, you can figure out the other formulas from it. And so don't be afraid to be creative and start making up your own formulas on the ACT and the SAT and stuff like that. Let me explain to you what I mean. The basic formula for area for any kind of quadrilateral or rectangle is actually the old standard one you learned for rectangles, length times width, which by tradition are written in cursive. That's why you had to learn cursive, just so you can write that formula. So the area of a rectangle is length times width. Or we could call them, instead of length and width, because sometimes kids get confused, we could call it base and height. Same thing. It's the same thing. Now, when you measure a height, it needs to be perpendicular to the base. So whichever base you're using, the height needs to be perpendicular to it. Of course it is in a rectangle or a square. But when you get into the weird things, like that, the height of this shape is 12 if this 12 is going to be our base. Now if we flipped it over, we'll talk about that in a second. But if this is our base, 12 is our height, and we don't measure 16, that's a slant height. It's bigger. It's shorter. This is if this is some weird little shape and you're up top and you jump down and you went straight down because of gravity, how far would you fall? Not if you slid off the back, because that'd be 16. But if you went straight down, how far would you fall? And it would be 12. So just always be careful you're measuring the right thing. So the area of a rectangle is length times width, or you could call it base times height. Okay, so what's the next one? The area of a square. So now, instead of having a rectangle, we've got a square. Well, I told you all of these formulas are the same, so the area of the square is length times width. Same thing. The only thing is, with the square, they're the same. So usually they're called side. So it could be length times width, or it could be side times side, or it could be side squared. Now, do you have to remember side squared to get the answer right? No. You could do length times width. And that's what the girl did wrong on the SAT. She panicked. She said, there's some formula and it has an exponent. Ah! If she had just remembered length times width, she would have gotten it right. Okay, the next one is a triangle. Have you ever noticed that if you have a triangle and you double it, what shape do you have now? You have a rectangle. So, and what is the formula for a rectangle's area? Length times width. So what's the formula for a triangle? It's 1/2 length times width. Or, how we're more used to seeing it, we call it 1/2 base times height. But really, it's the same thing. If you double a triangle, you get a rectangle. You have a rectangle So you have to cut it in half. You have to multiply by 2 or multiply by half or divide by 2. Now when you measure the height of a triangle, you have to make sure that it is perpendicular to the base. So this triangle, that would be the height. The right triangle, that would be the height. This one that's leaning over, the height is from the pinnacle to the base. It's the same as this. It's if you jumped off the pinnacle, how far would you fall? So the area of a rectangle of a triangle is 1/2 base times height. Okay? What about a parallelogram? Is that length times width too? Yes, it is. Okay? So here's my parallelogram. If we were in class together, I would make you get out an index card and do this. If you cut this off, okay, and I pick it up, imagine it's in my hand, and I put it over here, what shape do I have? A rectangle. So the height of a parallelogram, that's pretty terrible, the height of the area of a parallelogram is still just length times width. You just have to make sure that your height of it is going straight across here. So that's the height. This is the base. So it is the base times height, or height, I started to write height times base, but usually you call it base times height. Okay, so, but you got to remember, don't do slant height, do height, or else you'll get it wrong. It's got to be height. You got to use your scissors and cut it off. More if it's fun with sound effects. What about a kite? Well, I put my kite on a piece, see there's my kite right there. I put it on a piece of paper. And now I'm going to take my piece of paper and I'm going to fold it down. And I'm going to take my piece of paper here and fold it down. And I'm going to take this corner and fold it down. And I'm going to take that corner and fold it down. And there's my kite. Notice that each of these, with my paper behind it, it's 1/2. So the area of a kite is length times width divided by 2. We're taking off half of it. So, but you have to make sure that, so you do this diagonal is like your length, and this diagonal is your width, and then you divide it in half. So it's, we would call it base times height divided by 2 is the area of the kite. Now, in your book, these formulas are a little different. But it's the same formula, but how they're written might be a little different. I just want you to realize that they all go back to this length and width, and you're not going to forget them. You're going to be able to MacGyver them. Okay? A rhombus is actually like a kite. See, I put my rhombus on a piece of paper. Each paper could fold down to my rhombus. So we see that the rhombuses is the diagonals, or we won't call it base and height. I think we should call these diagonals instead. The diagonals multiplied and then divided by 2. Same thing here. Our diagonals are going to be multiplied, and since they're the same, well, not with the rhombus, we're going to multiply them and then divide by 2, because we're doing this line times that line divided by 2, because those corners are gone. Okay, what about a parallelogram? With this one, it's an average. We add up our 2 bases, divide them by 2, and multiply them times the height. Not the slant height, the height. The distance right there. So here is a parallelogram, and we want to get its area, which is base times height. So we could either do 12 times 12, or we could make this the base and do 16 times 9. Either way, it's 144. And on the SAT, they will often turn the shapes weird ways so that you don't see what you need to do. Okay, here's one. The area of a triangle is 52. Its base is 13. How big is its height? Well, the area of a triangle is 1/2 base times height. We sing the song Substitute, and we substitute 52 for area, leave 1/2, substitute 13 for base, solve for height. So to get rid of the one, what's making this ugly is the fraction, so I'm going to get rid of it by doing the opposite. And the opposite of multiplying by a half is like dividing by 2. So the opposite is multiplying by 2. These cancel out, and you're left with 2 times 52 is 104. Bring down what you didn't mess with. Now h is times 13, so we divide both sides by 13. The height is 8. Okay, here is a rhombus. These two are 15, those two are 20. So that means all the way across here it's 40 and across there is 30. So its area would be 30 times 40, base times height, divided by 2, 600. So that was my triangle there. All right, that's it for area. And come back next time, we'll learn more about shapes. How fun is that? Math is great.